Hey, it's asynchronous day on Friday. Right now I'm probably getting tested and hopefully I'll be negative and hopefully you guys will all be tested and you'll be negative. So I'm back at school and I'm gonna pretend that you're sitting here and paying attention, and you can stop this video at any time. All right, go over it. So that's gonna be sort of nice about this whole thing, and we'll see how it goes. So first thing we'll do is going to go over the homework. And let's start with number 53. A scuba diver takes a 2.8 liter pressure. A scuba diver takes a 2.8 liter balloon from the surface where the pressure is 1 atmosphere, it's 34 degrees, to a depth. So it's going to go to a depth of 25 meters, where the pressure is 3.5 atmospheres, and the temperature is 18 degrees. What is the volume of the balloon? Find the new volume. So when we're doing this, when we're doing any of these problems, we have to think about two things. We have to think about, are we going to use the combined gas law, or are we going to use the ideal gas law? So let's just put these up and hopefully you can see them. The ideal gas law. And the ideal gas law is when there's no change. And you've got PV equals nRT, and R is going to be equal to 0.082 atmospheres if we use atmospheres, or 8.314 kPAs. I hope that's not up too high. If it is, I'm in trouble. Or the combined gas law. And the combined gas law is when we have a change. So it's going to be P1 V1 over T1 N1 is equal to P2 V2 over N2 T2. So we have to think about those two. Now in this problem, I've got a change. There's a change. So if you write everything down, you'll never make a mistake. So I wrote everything down, and let's see what I have. I have 2.8 liters, which is equal to my pressure. I have 2.81 liters is equal to my volume. My pressure is equal to 1.0 atm, and the temp is equal to 34, which is going to be 34 plus 273. Now it's changing, so I'm going to 25 meters, where the pressure is, my new pressure is now going to be equal to 3.5 atmospheres, and my new temperature is going to be equal to 18 plus 273, and they want me to find my new volume. All right, so let's just set up our formula. We know we have a change, so I've got P1 V1 over T1 N1 is equal to P2 V2 over T2 N2. And I'm going to plug everything in. I'm going to get 1.0 atm times 2.8 liters divided by temperature, which is, 7, 9, and 4 is 1. 317, I hope that's right. And that's going to be equal to my pressure, which is 3.5, times my volume, divided by my temperature, which is 18, which is 291. And I solve for my volume. And my volume for this would be, the answer to this is 0.76. 0.76. Now, remember on this, temperature is always in Kelvin, And if we're using the ideal gas law, then my volume has to be in liters. So that's number one. Remember, that's 53. Remember, you can stop this anytime you want and take a look at it or play it back. That's what's nice about it. There's the first problem. Let's look at the second problem we have, which was number 55. 55 says a gas sample with a volume of 5.3 liters has a pressure of 735. So a gas sample with a volume of 5.3 liters has a pressure of 735 millimeters of mercury, and it's at 28 degrees. What is the pressure of the sample? So I want to find the pressure. P2 find. If the volume remains at 3.5 liters, but the temperature rises to 86. So P1, V1, T1, N1, and I'm going to plug in equals P2, V2 over T2, N2. And what do I got? My initial pressure is 735 millimeters of mercury. So I got 735 millimeters of mercury, which is the same as torr. Remember, it's also, or torr is the same thing. Okay? And then I'll divide that by the temperature, which is 28 plus 273. And that's going to be equal to my pressure. Volume. Did he give me a volume? Oh, I got to multiply this times. Excuse me, I didn't put my volume in here. Times 5.3. And that's going to be equal to, the pressure stays the same. Volume stays the same, so that's good. So now it's going to be my pressure times 5.3 liters. So these are both the same. I don't have to put them in. Divided by 86 plus 273. And the answer to that is going to be 877 millimeters of mercury. Okay, next, problem number 61. And 61 says a cylinder contains, there you go. 61, a cylinder contains 28 liters. See, I always write all this down so I know whether I'm using combined gas law or ideal gas law. A cylinder contains 28.5 liters of oxygen gas. So it's O2 gas at a pressure of 1.8 atmospheres and a temperature of 298 Kelvin. How many moles of gas are in the cylinder? Find moles of gas. Now, there's no change here. Here's the beauty of it. There's no change here at all. So then I'm going to use PV equals nRT. PV equals nRT. They want me to find moles of gas. Moles is N. So I'm going to get PV divided by RT is equal to N. Now remember, and I'll write this down, if I'm using this, PV equals nRT, it has to be liters. It has to be liters. Has to be liters. So, let's see what I got here. Pressure is 1.8 ATM. My volume is 28.5 liters divided by R, atmospheres. So I'm going to use 0.082 atmospheres for my R. And remember, I will give you your R. Times temperature, which is 298. And if I put that all together, 61, my answer will be 2.1 moles. Looks good. Great. You can always stop it, play it back. Hopefully this is large enough for you guys to see. If it's not, I'm gonna have to redo the whole thing. I will be very annoyed. Oh boy, hope not. 69. 69. An experiment shows that 248 milliliters 248 milliliters of a gas sample has a mass of 0.433 grams at a pressure of 745 milliliters of mercury. This is my pressure, and a temperature of 28 degrees Celsius. What is the molar mass? Find molar mass. I can't stress enough how important it is to write everything down when you start. To write it down. Now, nothing's changing, so I'm going to use PV equals nRT. And remember that N, which is number of moles, is going to be equal to the mass divided by the molar mass. So I can either plug mass divided by molar mass into N, or I can just solve for N and then plug it in. And that's what I'm going to do. I'm going to solve for N. So my pressure is 745 millimeters of mercury. I need to change that to atmospheres. So I'm going to get 745 millimeters of mercury, and I'm going to multiply that times 1 atmosphere over 760. That will give me my pressure. My volume is 248 milliliters, so I have to make that 0.248 liters. It has to be liters. Okay, that's my PV. Now, that's going to be equal to N times R, which is 0.0821, times temperature, which is 28 plus 273, which is going to be 28 plus 273. Now, if I solve for N, I get 0.00973 moles. 0.00973 moles. N equals that. Which looks about right. Yeah, it looks about right. And now I can say 0.00973 moles. That's going to be equal to my mass, which is 0.433 grams divided by my molar mass. And molar mass is going to be equal to 0.433 grams divided by 0.00973 moles. And that gives me an answer of 3.99 grams per mole. Let me just make sure that's right. Sample of that. Point that. Molar mass is equal to, what? Did I write something down wrong? Oh, Jeffrey. Oh, 38.8. Why did I say that? Oh my God. Did I put down the wrong? Oh. What problem was I doing? Oh gosh, 0.3, oh, 44 grams. That's right, 44 grams. I knew there was something wrong. All right. So, hopefully this helps that. And now let's go to the last problem you had, which was 71. Number 71 says a sample of gas has a mass of 38.8 milligrams, and the volume is 224 milliliters at a temperature of 55 degrees Celsius and a pressure of 886 torr. 886 torr. Find the molar mass. So we're going to find the molar mass. It's going to be the same thing. PV equals nRT. Once again, PV equals nRT. V equals nRT. And we're going to solve for n. N is equal to PV over RT. And so pressure is 886 torr. 886 torr. We'll change that to atmospheres. 1 atm equals 760 torr. That's my pressure. My volume has got to be liters. So it's 0.224 liters. I don't need that. Divided by R, which is 0.0821. Atmospheres times temperature, which is 55 plus 273, has to be Kelvin. That gives me 0.00973. 0.00973. Now I take 0.00973, 0.00973, yeah, and I've got to change 30, that's going to be equal to my mass over moles, 38.8 milligrams, 38.8, but now I've got to say 1 gram equals 1,000 milligrams, okay, divided by the molar mass. Divided by the molar mass, and what I get is 3.99. The molar mass equals 3.99 grams per moles. Just flip this up here. Okay, so that's last night's homework. Hopefully it makes sense to you. I've got a problem for you to do. I'm going to give you a problem. What I want you to do is shut off the phone, whatever you're watching this on, and do it. And then when you do it, then come back and I'll go over it. So here it is. What is the density? Find the density you're going to do this, of a sample of 1 mole of nitrogen gas collected at 0 degrees Celsius and 1 atm. Okay, turn it off, solve it, and then come back. All right, we're back. Let's take a look at this. Because it is 0 Celsius and 1 atm, I know that any 1 mole of any gas at STP, which is 0 and 1, has a volume of 22.4 liters. So density equals mass over volume. And that is going to be my mass of 1 mole of nitrogen gas, N2, which is going to be 28 grams, divided by 22.4 liters. So that becomes my density. Okay. Like I say, as I said before, you can stop it. Now, let's use, what's the next step? When we learn anything, the next step is always to see if we can stoich it. And yes, gas laws, we can use stoichiometry. So, here we go. 2 H2O liters, liquid, it's not a gas, is going to yield 2 H2, this is electrolysis, gas, plus O2, gas. Those are little G's for gas. Okay, how many moles of H2O? How many moles of H2O? How many moles of H2O are required, are needed to form 1.3 liters of O2 at 325 Kelvin and 0.988 ATM. Once again, shut it off, try it. Okay, we're back. Here we go. Now, this is what's interesting, is you have a problem and you want to find moles of H2O, but you don't have any information about H2O, but you do have information about O2. And by using this information about O2 and the ideal gas law, okay, and the ideal gas law, I can figure out moles of O2. So I want to find moles of O2 using the information that was given. Okay, how do I do that? PV equals nRT. PV divided by RT equals my number of moles. Okay, so here's what I do. Pressure is 0.988 ATMs times my volume, 1.3 liters, divided by 0.082 atmospheres, and the temperature, 325. That will give me my N. And unfortunately, did I not write that down? I did not write that down. But once we find what that is, then we can stoich that and say whatever N is, we can say 2 moles of H2O for every 1 mole of O2, and that will give me my moles of H2O. So that's stoichiometry. Using stoichiometry, we solve for number of moles of O2, and then we stoich to whatever we want. So what I want you to do right now is in your packet, the packet I gave you of problems, it says honors problems, I want you to do problems 3, 6, and 9. I want you to do problems 3, 6, and 9 right now. Now, I'm going to do the solutions to them. So your choice is to do one problem at a time and then come back and look at it, or do all the problems and then come back and look at it. But shut it off now. I'm going to get a water to drink, and then and that's what we're going to do. Okay, I'm back. Let's see if we can solve these problems 3, 6, and 9. Okay, 3, 6, and 9. Number 3, calculate the volume of H2 produced at 1.5 atmospheres and 19 degrees Celsius by 26.5 grams of zinc with excess H2O. Zn, once again, we write the equation first, plus 2HCl yields ZnCl2 plus H2. And what they want me to do is the volume of H2. I want to find volume right over there. And they give me 1.5 atmospheres. They give me information of zinc. Cool. So what's for zinc? They're giving me 1.50 ATM. Oh, at 1.50. Oh, wait, no. Find volume, and I've got 1.5 ATM and 19 degrees Celsius. Excuse me. That is for hydrogen. I forgot. Hydrogen's a gas. Zinc, they're just giving me 26.5 grams. So I want to find the volume. Oh, cool. So in this case, I go right here and I say PV equals nRT. I'm going to plug in. And I've got 1.5 atmosphere. They want me to find the volume equals nR, which is 0.0821, times the temperature, which is 19 plus 273. So what I have here is I have two variables. I have volume and number of moles. So I need to solve for one of those to solve for volume. I need to solve for N. How do I do that? Well, I do that from going zinc, and then I can go mole to mole ratio using the zinc. And let's see what I got here. I've got 26.5 grams of zinc. Let's change that to moles. 1 mole divided by 65.38 grams gives me 0.405 moles of zinc. Now I go mole to mole ratio. 1 mole of H2 for every 1 mole of H2 for every 1 mole of zinc. So I get 0.405 moles of H2. Then I plug in the 0.405 moles of H2 into this, and what I come up with is 6.47 liters of H2. So what I've done here is I want to find the volume, but I don't know what N is, but I can stoich it from the zinc. So when you have two variables, what you do is see if you can find one variable, which is usually going to be moles, by using stoichiometry. Okay, that's number 3. I think we're going to do number 6 next. Okay, you can go back and do that. Let's look at number 6. Whoa. Number 6 has when 89.5 grams is roasted with excess O2, what volume of SO2 is produced at this. This is very similar to problem number 3. We have two variables, and what we need to do is we need to solve for N so we can use it in PV equals nRT. So I need to find the moles of SO2. So I can plug it in. So I've got 89.5 grams of Ag2S3. I'm going to change that to moles. 1 mole is going to be 246.05 grams. Now I'm going to go mole to get to SO2, and I get 6 moles of SO2 for every 2 moles of AS. Why did I say AS? Is it AS or AG? AS. Excuse me, AS. AS to S3, and that gives me 1.09 moles of SO2. Now I've got enough information to use PV equals nRT, which is pressure. What's the pressure here? The gas product is 98.0 kPAs. kPa. Pressure times my volume. And I'm trying to find my volume. Equals N, which I'm going to say is kPAs. So it's 8.13 kPAs. That's my R. And temperature is going to be, what is my temperature? What did it say? 22, it said 22 degrees, 20 degrees. 20 degrees, so it'd be 293. PV, I need an N. Ooh, where's my N? I forgot my N. Well, my N I get from right here. So that's 1.09 moles. And now I could just solve for V. And if I do it correctly, I get 1.09 times 8.39 times 273 divided by 98. Beautiful. 27.1 liters. Okay? Beautiful. Now, problem number 9. Let's look at problem number 9. Problem number 9. What mass of HgCl will react with that, at that, and that? Let's see what we got for number 9. I think it's done pretty much the same. I need to find the number of moles. Need to find the moles of NH3 that react. Okay? And that's going to be done pretty much the same way. What's the mass of mercury chloride will react with 0.567 liters of ammonia at 27 and that. So what I'm going to do is find the number of moles of NH3, which is our ammonia that react. So I'm going to use PV equals nRT in this case. And I'm going to get my pressure. My pressure is going to be 102.7 kPAs. And my volume is 0.567 liters. That's going to be equal to my N, which I'm trying to find, times R. And I got kPAs, so it's going to be 8.13